all, today we're doing 10.6, Counting Principles, Permutations, and Combinations. I hope you enjoy. Let's go. Our objectives are to use the fundamental counting principles, to use permutation formula to distinguish between permutation problems and combination problems, and to use combination formula. So the first thing on our list is the fundamental counting principles, the number of ways in which a series of successive things can occur is found by multiplying the number of ways in each of the things could occur. So, on our piece of paper, I have that the number of ways, I gave you the definition, so you're going to pick out outfits. So, you have to pick out an outfit now for our stay-at-home order, and you have 2 pairs of sweatpants, and you have 4 t-shirts. Shirts. So our pants you have are, I will put jeans and sweatpants. I'm just going to call those SP for short. And over here you have shirts. You have a red shirt, you have a pink shirt, you have a blue shirt, you have an orange shirt. Okay, so the way we have this is you can have your jeans or your sweatpants. And then once you put on your jeans, you know you have the option of a red shirt, a pink shirt, a blue shirt, or an orange shirt. And when you put on your sweatpants, you have the same options. You can put on your red shirt, your pink shirt, your blue shirt, or your orange shirt. So how many options did we have? We had jeans with red shirt, jeans with pink shirt, jeans with blue shirt, jeans with orange shirt. You have sweatpants with red shirt, sweatpants with pink shirt, sweatpants with blue shirt, sweatpants with orange shirt. So you technically have 8 options. So 8 options. But we also could have gotten this by you have 2 types of pants and 4 types of shirts. And we know that 2 times 4 is 8. And this is the fundamental counting principle. Okay, so our next example is a pizza can be ordered with 3 choices of size. Small, medium, and large. 4 choices of crust, thin, thick, crispy, or regular. And 6 choices of toppings, ground beef, sausage, pepperoni, bacon, mushroom, or onion. Those all sound terrible. How many different one-topping pizzas can be ordered? So we know we have our size. We have 3 options. We know our crust. We have 4 options. And we know toppings. We have 6 options. So to find it, we do 3 times 4 times 6. So 24 times 3, which is 72. I said 72, I wrote 27. 72 different one-topping, got a second P in there, pizzas. So we have our try it yourself. So next semester you're planning on taking 3 courses, math, English, and humanities, based on the blocks and highly recommended professors. There are 8 sections of math, so math, 8 sections. English, you have 5 sections. And humanities, you have 4 that are suitable for you. Assuming there are no scheduling conflicts, how many different 3-course schedules can you have? Well, you could have 8 times 5 times 4. It's a weird 5, but it is a 5. But we know these are 20. 20 times 8 is 160 different 3-course schedules. Okay, so now we're on to permutation. A permutation is an ordered arrangement that occurs when no item is used more than once, and the order of arrangement makes a difference. So order makes a difference. No item more than once. So the number of possible outcomes for the permutation are if R items are taken from N items. We have N factorial over Pn minus R factorial. You can also see it in this form, NPR. Okay, so in how many ways can 6 books be lined up along this shelf? So, because we are going to be using all 6 books in every possible arrangement, we want to be using our R being 6 because that's the total books, and we're choosing 6 books from that group. So we have our N, which is 6, P, which is 6. So from a total of 6, we're choosing 6, which means we can rewrite these as 6 factorial over, and then it's going to be 6 minus 6 factorial. So 6 factorial over 0 factorial. We know 0 factorial is 1. So we have 6 factorial, which is 6 times 5 times 4 times 3 times 2. If you guys have your graphing calculators, you actually have a button that does both of these. I still want you guys to do it with me with showing the work, but there is a permutation button, and it's going to be underneath the probability button or under math, depending on which calculator you have, and you have a factorial button that will do that as well. I'm sure you guys remember the factorial button from Algebra 2, but I don't know if you guys touched on the permutation button and the combination button on your calculators. So we have that going. If you multiply all those together, you arrive at 720 ways. So if you were just trying to have a great, I don't know, day of the week this is, and you're like, I'm so bored, I want to rearrange my 6 books on my bookshelf. How many ways can I do it? Well, this is your way. You have 6 books to put in your first slot, and once you fill that, you only have 5 books left. So your second slot has 5 options, and then your fourth spot, your third spot has 4 options, your fourth spot has 3 options, your fifth spot has 2 options, and your sixth spot just has 1 option because you're putting one of those books away each time. Okay, so now let's go on to our try it yourself. So here we have a try it yourself. They have 13 players on a baseball team. How many ways can a manager choose the lineup? I have no idea what I was trying to write there. On baseball team, how many ways can the manager choose a lineup? Okay, so you can look at this a couple ways. A very visual way is you know that you have 9 batters in baseball. So batter 1, batter 2, batter 3, batter 4, batter 5, batter 6, batter 7, batter 8, batter 9. Saw my dyslexia there. And since there's 13 players, you have 13 people who could fill the first position. You have 12 people, now that you've assigned somebody to first position, to fill the second. 11 people, 10, 9, 8, 7, 6, 5, and then we multiply all these together, and you get an answer. Which that answer happens to be 259,456. Or you could do it using the other way. So we have 13 players, and we are choosing 9. So you end up with 13 factorial over 13 minus 9 factorial. Well, 13 minus 9 is 4. So you end up with 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, all over 4 factorial, and these cancel. And then you're left with exactly what we had up here. So you know this is your answer. Okay, that's as far as we're going today. So we did permutations.